Today we're going to be dividing monomials. Yesterday, you took a powers to a power, and the day before that you multiplied. So, if I gave you the equation, or the fraction, 12/20ths, and I asked you, is that simplified? What would you tell me? And why is that? Why is it not simplified? Most of you would look at that and say, well, I can divide by another number other than 1, which is true. But this is really what you're doing. You're taking 4 times 3 and 4 times 5, and you're crossing out a common factor. And you're canceling it, because 4 divided by 4 is 1. Anything divided by itself is 1. And you're left with 3/5. There's something called the cancellation property of fractions. And what the cancellation property states is this. If you have two numbers, or two things multiplied by each other, and they're the same factor, they cancel each other out. So a times c over a times b would leave you with the fraction of c divided by b. So now let's say we actually have variables. We have a monomial. We have a monomial, a to the 5th, divided by another monomial, a squared. Here's really what you're doing. A to the 5th is a times itself 5 times. A to the 2nd is just a times a. Using our cancellation property that I just showed you, anything divided by itself is 1. So all of these a's will cancel. So that leaves you with a to the 3rd power over 1, which is just a to the 3rd. In addition, if I switch that around, a squared over a to the 5th, you'd now have a times a on top, and you'd have a product of 5 a's on bottom. These a's would cancel, but this is a little different. You're still left with anything divided by itself. These are all 1s. We don't usually write them, but that's what they are. So you're left with 1 times 1 on the top, which gives you 1 over a times a, which is a to the 3rd. This is called the quotient of powers. Basically, we subtract. That is all you're doing. 5 minus 2 gives us 3. Now let's think about this. What is 2 minus 5? 2 minus 5 is negative 3. But you should remember that a to the negative 3rd gives you that. So I'm going to teach you a shortcut so you don't have to worry about negative exponents today. But everything is going to start tying into each other. For example, the negative exponents. 2 minus 5, once again, 2 minus 5 gives you to negative 3rd power, which we can't have that. So your answer is 1 over a to the 3rd, or 1 divided by a to the 3rd. On all of the examples we're going to be doing, we're going to be simplifying. So let's start with example number 1. X to the 8th over x to the 5th. Now, when you have the same base, when you multiply with the same base, you add the powers. So, obviously, if you're dividing with the same base, x and x, if we're dividing, you're just going to subtract. 8 minus 5 gives you x to the 3rd. But here's what I would do. I look at this and say, where are there more x's? On top or bottom? On top. How many more x's are on top than the bottom? 3. So x to the 3rd is going to be over 1, which means we just write x to the 3rd. Example number 2. Y to the 9th divided by y to the 9th. 9 minus 9, that gives you 0. Anything to the power of 0 is 1. That's why any number or anything divided by itself is 1. Number 3. Z over z to the 5th. Now the power on the top z is 1, and you're actually going to get 1 minus 5, which is negative 4, but that's going to give you 1 over z to the 4th. A common mistake is people just want to take 5 minus 1 and get z to the 4th. Here's my trick. Where are there more z's? On top or bottom? On bottom. So that means, how many more z's are on bottom? 4. So your z to the 4th is in your denominator. Let's try another one. A to the 3rd, b to the 2nd, c over a to the 7th, And let's make this c to the 5th. Let's start with our a's. I'm going to use my shortcut. Where are there more a's? On bottom. How many more a's are on bottom? A to the 4th. B squared divided by itself cancels, it's gone. Where are there more c's? On bottom. How many more are on bottom? 4. So you have 1 left on top. Your answer is 1 divided by a to the 4th times c to the 4th. Number 5. Negative 15 a squared b to the 3rd all over 5 ab to the 8th. So let's start simplifying. 15 and 5. Well, 15 divided by 5 is just 3, and that's negative 15. So negative 15 divided by 5 would give us negative 3. Where are there more a's? On top. How many more are on top? Just 1. So we have a to the 1st, or a. Where are there more b's? On the bottom. How many more? 5. So my answer is negative 3a divided by b to the 5th. Example number 6. Start simplifying. 18 divided by 27. What is a common factor of 18 and 27? It would be 9. 9 goes into 18 twice. 9 goes into 27 3 times. So 18 27ths simplifies to 2/3. X to the 3rd divided by x to the 3rd. Those cancel. That gives you 1. Y to the 4th over or divided by y squared. Where are there more y's? On top, so it'd be y squared. Z divided by z to the 5th. Where are there more z's? On bottom, there are 4 more, because 5 minus 1 is 4. So, 2y squared divided by 3z to the 4th. Number 7. Number 7, we now have to follow order of operations and use the rules we've learned in previous days. The first thing I have to do is I have to get rid of this exponent. We're taking 3x to the 5th y squared. So let's square everything. 3 to the 2nd power is 9. X to the 5th to the 2nd. Our rule states powers to powers, I multiply them. So that gives me x to the 10th. And 1 times 2 would give me y to the 2nd. 6x to the 4th, y to the 3rd. Comes down. Start simplifying. 3 goes into 9 and 6. 3 goes into 9 3 times. 3 goes into 6 twice. So that gives me 3 on top, 2 on bottom. X's. Where are there more x's? There are 6 more x's on top. Where are there more y's? There is 1 more y on bottom. So when you subtract, that's how you know where your variables go. My final answer is 3x to the 6th divided by 2y.